Hi geometry students, welcome to week 6 where we're going to be learning about volume applications, displacement, and density. You might be a little familiar with displacement and density from a science class before, so some things might be a little bit familiar. Feel free to pause this video at any time if it's going too fast and you're trying to copy the notes, or you can rewatch it as well. Take a look at this first example. It says the volume of a cylinder is 628 centimeters cubed. Find the radius of the base if the cylinder height is 8 centimeters. So imagine you're some kind of package designer and you have some volume. Maybe it's a volume of liquid that's 628 centimeters cubed, and you know you want to package something in a container that's 8 centimeters high, and so you need to figure out what the radius has to be. So it's always really helpful. You can see over here I wrote to draw a diagram to help you when you come across a problem like this. Please always do that. So let's take a look at this problem. If you remember, the volume formula for any sort of prism is the area of the base times the height. Notice I use the big B to represent the area of the base, not like the base side of a triangle or something like that. No, we're talking about the area of the base. We represent it with a capital B. So in this case, we know the volume is 628 centimeters cubed, so I'm going to substitute that in for V. The area of the base of a cylinder is a circle. So to find the area of a circle, it's pi times r squared. I don't know what my r is. That's what I'm going to solve for. And my height I'm given is 8 centimeters. So times 8. So I'm just now going to solve this for r. I'm going to first divide by 8 on both sides. When I take 628 divided by 8, I get 78.5. Then I'm going to divide by pi on both sides, or I think I'll just use my 3.14 on my calculator, and I end up getting 25. And so now I'm just going to take the square root of both sides, which ends up being 5. So the radius has to be 5 centimeters. The next topic I want to talk about is displacement. So displacement's the volume of liquid that's pushed away when an object is placed into it. So imagine that you're in a bathtub, you get in the bath, and the bath water rises. The amount that it rises is the displacement, that volume. As you can see, the displacement is an easy method to find the volume of an irregular shaped solid object. So take a look at example 2 with me now. You put an irregular shaped rock into a container and it raises the water level 2 centimeters. If the container is a rectangular prism whose base measures 15 centimeters by 10 centimeters, what is the volume of the rock? So you can see the before and after picture. And in the after picture, you can see there's this slice, so to speak, this rectangular slice that is 2 centimeters high, that it's been displaced. So we want to figure out the volume of that slice, because that's going to be the volume of the rock. So the volume of this slice is, let's think about how to find the volume of a rectangular prism. That little slice is a rectangular prism. If you remember, we take the area of our base, the big B, times the height. Well, this has a rectangular base, so the area of my base is 10 times 15, length times width. The height is the height of my slice is 2. When I multiply those numbers together, I end up getting 300 centimeters cubed. The irregular shaped rock has a volume that's equal to the volume of that water that's displaced, so the rock's volume is the same. It's also 300 centimeters cubed. The last topic we're going to discuss for this week is density. Density is the mass of matter in a given volume. You can find the mass of an object by weighing it, so thinking about its weight in kilograms or pounds or ounces. And as you can see, density is calculated by dividing the mass by the volume. So let's write that formula out. Density equals mass divided by volume. Let's take a look at an example involving density. A clump of metal weighs 351.4 grams, is dropped into a cylindrical container, causing the water level to rise 1.1 centimeters. The radius of the base of the container is 3 centimeters. What is the density of the metal? So first, I need to find the displacement to know the volume. We'll then use that volume value in our density calculation. So let's remember our volume formula. The area of a base times the height. And the area of a base of a cylinder is a circle. So it's pi r squared, or in this case, pi times 3 squared, since 3 is the radius. And the height that it's displaced, the height of the slice that's the water is displaced, is 1.1 centimeters. So if I enter that in my calculator, I end up getting 31.086 centimeters cubed. All right, so I've got that for my volume. That's the volume of the water that's displaced, which then equals the volume of the metal. So the second thing I'll do is I'll use the density formula to figure out the value. So remember that density is equal to mass divided by volume. So I'm going to take my mass of 351.4 grams and divide it by my volume of 31.086 centimeters cubed. And I end up getting 11.3 grams per cubic centimeter. So there's 11.3 grams in each cubic centimeter of that piece of metal.